Hello everyone. Today our topic of discussion is Lagrange method of multipliers. Sometimes it is required to find the stationary value of a function of several variables which are not all independent but are connected by some given relation. We try to convert the given function to one having least number of independent variables which with the help of a given relation, then solve it by Lagrange method. In Lagrange method, we are given a function f(x,y,z) and we have to find the maximum or minimum value of a function of this function. But a condition is also associated with the given function, and with the help of that condition, we will find the maximum or minimum, or we can say extreme value of a given function. Here is the working rule of Lagrange method. Number first, consider the function u equal to f(x,y,z) where x, y, z are connected by relation phi x, y, z equal to 0. Here the given function is u, or we can say f, and the given condition is phi. U and phi both are functions of x, y, and z. And number two, find du, and du equal to del f del x into dx plus del f del y into dy plus del f del z into dz. And same for the phi del x into dx plus del phi del y into dy plus del phi del z into dz equal to 0. Now substitute du equal to 0, then equation number first becomes del f del x into dx plus del f del y into dy plus del f del z into dz equal to 0. This is our equation number 3. And for maxima and minima, multiply equation 2 by lambda and adding to 3. Then what will we get? Del f del x plus lambda del phi del x into dx plus del f del y plus lambda del phi del y into dy plus del f del z plus lambda del phi del z into dz equal to 0. This is our equation number 4. Lagrange's identity holds if del f del x plus lambda del phi del x equal to 0, that is lambda equal to minus del f del x divided by del phi del x. And second one is del f del y plus lambda del phi del y equal to 0, which implies that lambda equal to minus del f del y divided by del phi del y. And third one is del phi del z plus lambda del phi del z equal to 0, implies that lambda equal to minus del f del z divided by del phi del z. Now put the value of x, y, z in the given equation. We will get the extreme value, or we can say maximum or minimum value of the given function. Lagrange's method doesn't enable us to find whether there is a maximum or minimum. This is the drawback of Lagrange's method, that it doesn't enable us to find whether there is a maximum or minimum. The above equation can be easily obtained by considering Lagrange function capital f(x,y,z) equal to small f(x,y,z) plus lambda phi x comma y comma z, and considering the stationary values of f(x,y,z). For a stationary value of f(x,y,z), we'll put df equal to 0. Now we'll take a problem based upon the Lagrange's method of multiplier. Question is, show that the rectangular solid of maximum volume that can be inscribed in a given sphere is a cube. Now we'll solve it. Let 2x, 2y, 2z be the length, breadth, comma, and height of the given rectangular solid and let capital R be the radius of the sphere. Then we know that the equation of sphere is x square plus y square plus z square equal to r square, and which will be treated as our condition. We know that to solve the given problem by Lagrange method, will consider a function as well as a condition. So x square plus y square plus z square equal to r square, or we can say x square plus y square plus z square minus r equal to 5xyz. This is our equation number first, and the given function is f x y z, which is our volume, that is v equal to 8xyz. We know that if 2x 2y 2z be the length, breadth and height of a given rectangular solid, then the volume will be represented by 8xyz, that is multiplication of length, breadth and height. This is our equation number second. Now we'll consider Lagrange function. Now we'll consider Lagrange function capital f x y z equal to f small x y z plus lambda into phi x y z. Lagrange's function capital X is the combination of function f x y z plus lambda into given condition. First, we will find the value of df. And we know that what is df? Df will be differentiate the given Lagrangian function with respect to x, y, z, del f, del x plus lambda into del phi, del x, dx, del phi, del y plus lambda into dy plus del f, del z plus lambda, del phi, del z. df equal to del f del x plus lambda del phi del x into dx plus del f del y plus lambda del phi del y into dy plus del f del z plus lambda del phi del z into dz. And we know that for stationary values we will put df equal to 0. Now we'll differentiate the given function with respect to x, y, z. And first we'll consider the function f x, y, z equal to, we are given a small f x, y, z equal to x square plus y square plus z square minus r square. And the value, this is the, this is capital F is equal to given function, which that is 8xyz plus lambda into given condition, and condition is x square plus y square plus z square minus r square. Now we'll differentiate the given function, Lagrange's function. So df equal to 8, will differentiate 8xyz with respect to x. What will get? 8yz plus lambda into 2x into dx plus 8 xz plus lambda into 2y dy plus 8 xy plus lambda into 2z dz. This is the differentiation of the given function as well as given condition with respect to x, y, z. Now, for stationary values, we know that for stationary values, this is considered as a equation number, like equation number 3. We know that for stationary values, we put df equal to 0. So, for stationary values, put df equal to 0. Then 8yz plus lambda 2x into dx plus 8xz plus lambda 2y dy plus 8xy plus lambda 2z dz equal to 0. The whole equation is equal to 0 implies that 8yz plus lambda 2x will be 0. 8xz plus lambda 2y equal to 0 and 8xy plus lambda 2z equal to 0. This is our equation number 4, 5 and 6. Now we multiply equation 4 by x comma equation 5 by y and equation 6 by z. I will multiply x in equation number 4, y in equation number 5 and z in equation number 6. What will we get? 8xyz plus lambda into 2x equal to 0. 8xyz plus lambda into 2y square equal to 0. 8xyz plus lambda into 2z square equal to 0. Now we can easily see that 8xyz equal to minus lambda into 2x square. From second, 8xyz equal to minus lambda into 2y square. And from the equation number 3rd, 8xyz equal to minus lambda into 2z square. We can easily see that all the values are equal to 8xyz. So implies that minus lambda into 2x square equal to minus lambda into 2y square equal to minus lambda into 2z square equal to 0 implies that x square equal to y square equal to z square equal to 0 implies that x equal to y equal to z. And we know that if all the dimensions are equal, then we can say given figure is a cube. So now we conclude that hence rectangular solid which is inscribed in a sphere is a cube because all the dimensions are equal. So this is the answer of our question. Here are the references. Disclaimer. Thank you. Thank you everyone for watching.